Welcome back to the channel. So today we'll be looking at the today's lead code question, which is remove the nth node from the end of the list. Here we are given a linked list and then we need to remove nth node from the end of the linked list. So let's say we are given head of a linked list and we need to remove nth node. So let's observe this particular scenario. Here the n is 2 and then the size of the linked list is 5. So this is 5 and then this nodes will be 2. We need to remove 4 from this, and then let's say how can we solve this via brute force approach. Suppose we'll calculate the length of the linked list and then we'll try to reduce this particular 2 and then we'll traverse all the elements which are present, and then when we come here we are going to say 3 dot next equal to 3 dot next. So this will be pointed like this and that will be the answer. So if we do this particular step, then we are going to say we are doing this via 2 pass. Why? Because we are traversing first time for calculating the size of the linked list, and then again we are doing the traversal for finding out the nth node from the end of the linked list. So instead of here it is given that we should could you do this in one pass? So it should be done in only one pass. So how can we do this? Let's suppose think this as a linked list and then let's say this is 2, and then let us assume that we'll have two elements, the whatever this is n and then this is also going to be n, and then let's say the total size is s, and then let's take this in between distance as y. Okay, for this particular case if we observe, so if we want to do it in one pass, then let's start from the starting, and then let's go through everything, all the nodes which are present in the linked list. Let's go through all of them. When we are going through all of the elements, we need to find this particular position. So to find this particular position, we need only this part, which is 2 plus y. But we don't know what is a y, but we know what is 2. So let's take this particular path. If we travel from here to here, the distance will be 2 plus y, and then if we travel from here to here at the end, the distance will be y plus 2. So if we travel with this from the same place, and then let's say we'll travel first with the 2 with 2 distance, and then when we are done with the 2 distance, we'll start one more pointer from the starting, and then we'll get to here y, and then again it will be traversed at this, we'll get here y, and then this will be 2, and then when we are done with this, the first pointer will travel like this, and then the second pointer is going to travel 2 plus y. So the distance traveled by both of them will be same, and then one will end up at the last, and then the second pointer will store this particular pointer. So from the previous we can say previous next equal to previous next. So that is how we are going to solve. So the main idea for this particular problem is we need to figure out the um, way such that both of the pointers travels the same distance, and then from the nth node we'll get to know what is the node from when we are going to travel. So let's see the code so that we can understand better. So for this particular code, here we have taken three nodes, which is first node and then second node and then previous node. Previous node will store the previous node. Let's take this particular first node, and then till first node becomes null, we are going to travel this, and then whenever we say the count equal to n node, then we are going to assign the second node equal to head, so that it will start traversing from the first until to some x plus y. And then if we have a second node, then we are going to store the previous node from the second node, and then we are going to traverse the second node to second next, and then we are going to increment count, and then for this first node we are going to traverse to the next. And then one more thing is, suppose let's say previous node is null, then it is going to be this particular case, so we need to remove this particular node. So we can say that head becomes head plus next, and then we are going to return head next. And then if it is not, then if we have previous node, then we are going to say previous node next becomes previous node next. So this is going to be like this, and then we are going to return the head. Yeah, that's all for this video. And then if we come to the space complexity, we are not taking any space, so it will be big O of 1. And then coming to the time complexity, it is going to be big O of n. Yeah, thanks for watching the video. Have a nice day.